Welcome to yet another Smar video. This video aims to demonstrate through a ready configuration in System302 using foundation Fieldbus technology performed on a closed test containing 22 char with the simulation view simulator. Let's categorize our project into specific zones. Simulate. Click the gear icon in simulation view. It will configure our simulator. Next, we will access our project. In the flow loop, open the channel. In window tiling, divide it. There. By selecting the detailed glasses within our application, we are able to visually observe the functional blocks that were arranged. They were done there to act, the run, the transfer function, the PID, and the output. Including an analog input block is required. Examine our strategic plan in depth. PID control. Notice that we inserted the transfer function block. We can observe the parameters entered to simulate. The strategy, the transfer function block. We will guarantee that our control loop functions automatically and provides a prompt response. Send it. The signal to the PID. The PID will run in automatic mode. We applied a preliminary tuning, a gain of 1 and 10 proportional. And the analog output block that is going to be the control of the valve, we also placed it in a cascade. And it's set up there, our control mesh for simulation. The tags are ready to be exported. Let's start the process. Exporting tags gives us hours, the potential for online monitoring, download on the simulator, maximize fidelity. Remembering that in this case we don't have the hardware, let's send for the simulation, just like we would have the controller. Let's start. Let's send for our sim. Let's please maximize the window and click on the online simulation button. And our control network is already responding. It is functioning online. With this, we can successfully conduct the closed loop simulation, and that is what is important. Let's minimize some windows here, and we will be able to open any block. For example, open it there, PID block, online, and track to the plan via blocks. Let's adjust the windows. We're here monitoring online our closed control network, simulating our network. We also have the PID block online. Furthermore, our control strategy remains available online. Let's open the supervisory system there. Put in the runtime option. We can see with this that our process is already running. Change the set point to 50%. In the graph, the set point appears in green, while the process variable, the flow rate, is in red. The valve is represented in blue. We can see already the online reaction of the system. the process's response. So with this, we can perform the simulation by using Studio 302 software with the supervisory system, using the resource of a transfer function block, the PID and output in the store. Let's adjust the set point again. I will set it to 30%. We're calculating in terms of percentages. Observe the green line that moved to 30%. The PID control is automatically adjusting to the process variable. As we see in the trend chart, there is an observed pattern, and we can also see in terms of values. Now, let's set another value, 80%. We increased our set point to verify the valves opening and the rise in our process variable. In this case, we're simulating flow rate. There is no. The flow rate is rising, reaching for our set point. You have the option to adjust the tuning for potential improvement. The response of the process curve, this is possible too. So we observe the values, our simulation, as well as we can verify in the graph, monitoring via Syscom online, watching the blocks, unlocking obstructs on the internet in order to observe. Therefore, we have the tuning in closed loop, APV equal to set point. We can now operate the control loop to function properly on its own.